Okay, let's unpack this. Imagine you are trying to describe a highly detailed painting to someone standing over half a mile away.
Right, and they have to perfectly recreate it.
Exactly, yeah. Perfectly recreated, 60 times a second.
Oh,
So today we are taking a deep dive into an HDTVSupply product page that actually pulls this off.
yeah, we are looking at the PureLink OLC-III-TX RX DVI over 1 LC fiber extension system.
Which is a mouthful, I know. But the mission here is to see how this industrial-grade tech solves massive video distribution problems for commercial spaces.
Right, and to pull off that recreation at half a mile, well, this system completely abandons traditional copper wire. It takes a standard DVI video signal and converts it entirely into pulses of light.
Wait, let me stop you right there, because here's where it gets really interesting. I'm looking at the price tag, and it's like $1,800, right?
Yeah, it is definitely a serious investment.
Yeah, but DVI is a legacy standard. It maxes out at a 1920 by 1200 resolution. I mean, I can get a 4K HDMI extender online for $50.
Yeah, you can.
So why on earth are commercial spaces paying this massive premium for an older standard?
Well, it really comes down to the physics of those light pulses. Consumer extenders usually rely on copper, and that degrades quickly over distance.
Oh, right. It just loses signal strength.
Exactly. This system uses fiber optics. Specifically, if you use a single-mode fiber optic cable, it can transmit that 1920 by 1200 signal at 60 hertz up to 0.62 miles.
Wow, so a full kilometer.
Yeah.
Like 300, 280 feet.
Yeah, exactly. But if you use multi-mode fiber, the specs say the range drops down to 984 feet.
Wait, why the huge difference in distance?
It is all about how the light travels, you see. Single-mode fiber uses a microscopic core and a laser to shoot light in a perfectly straight line.
So no bouncing around or anything.
Right, no bouncing means no signal degradation. Multi-mode, on the other hand, uses a wider core and an LED light.
Ah, so it bounces off the internal walls of the cable as it travels.
Yep, and all that bouncing scrambles the signal over extreme distances. That is why the effective range drops off so steeply with multi-mode.
Okay, so you have this flawless signal traveling via laser over half a mile. But bridging that physical gap usually creates a massive software headache.
Oh yeah, anyone who deals with commercial AV knows that pain.
Right, because EDID handshakes notoriously time out or just fail over long cable runs.
And that is actually the second reason for the premium price tag. It is the Smart ED management feature.
Smart EDID.
Yeah, because over half a mile, a display and a video source just cannot reliably talk to each other in real time to negotiate resolutions.
So what does the PureLink do then?
It acts like a highly trained diplomat, basically. It automatically learns and stores the display's ED data locally.
Oh, wow. So instead of the video source shouting across a kilometer of cable trying to figure out what the monitor can handle, the transmitter module right next to the source steps in?
Exactly. It just says, don't worry, I already know exactly what the display needs.
That is wild. Instant, flawless compatibility without any manual tinkering.
Right. It solves the software handshake problem entirely. But what's fascinating here is how it handles the physical headaches of installation.
Because commercial AV racks in massive sports bars or industrial control rooms are usually crammed with dozens of amplifiers and receivers.
Oh, they are literal ovens. They generate immense heat.
Which makes the footprint of these modules even more impressive to me. These detachable transmitter and receiver units are tiny.
Very tiny.
They're only 3.5 inches long and weigh a mere 0.2 pounds each. I mean, you could lose one in your pocket.
You really could. And more importantly, the spec sheet notes they draw less than 2 watts of power.
2 watts. That is nothing.
It is nothing. And that ultra-low power draw is the exact mechanism behind their survival.
Ah, because they do not generate their own internal heat?
Precisely. There is no need for a built-in cooling fan that could eventually break down.
Oh, that makes sense.
That specific engineering choice allows them to operate in blistering environments. We are talking up to 131 degrees Fahrenheit, or 55 degrees Celsius.
Wow, consumer-grade tech would simply melt down in those racks.
It absolutely would.
So what does this all mean for you listening? Well, the next time you walk into a giant sports bar or an airport and see flawless, lag-free video running perfectly across dozens of screens, you will know what is really going on behind the walls.
Right, you are looking at the invisible heavy lifting of tiny, fanless fiber optic workhorses like the PureLink OLC-III.
It really is amazing.
It really shifts your perspective on how infrastructure is built. I mean, we started by imagining and describing a painting from half a mile away.
right?
So if a pocket-sized 3.5-inch module can perfectly intercept a digital handshake and transmit a dense video signal via laser across a kilometer of fiber optics today,
Yeah.
it leaves you wondering, how close are we to a world where physical proximity between any of our digital hardware components becomes completely irrelevant?